Welcome back on the lecture series of topics Some Basic Concept of Chemistry. Today we are going to study about mole concept. So let's get started. First we see the definition of mole, which is defined as the number of atom in exactly 12 gram of carbon-12. 1 mole of molecular compound contains Avogadro's number molecule and has a mass equal to the substance's molecular weight in grams. Mole is often abbreviated as MOL. Now we see about definition of molar mass. The mass of 1 mole of a material. This is the molar mass. For example, the molar mass of water is 18 gram, obtained by adding twice the molar mass of hydrogen to the molar mass of oxygen. Now we see about the Avogadro's number, which is given by the Amedeo Avogadro. He is an Italian chemist and physicist. The number of particles in 1 mole equal to 6.022 into 10 raised to 23 per mole. Finding the molar mass, for example, we take water. For that, 1 mole of oxygen and 2 mole of hydrogen is present. Multiply molar mass of each element by the number of moles of that element in the molecule. So 1 into 15.9. This is for oxygen and 2 into 1 for the hydrogen. So it comes out to be 2.015. Add these two numbers, you get 18.02 gram per mole. A second example for this is we take NaOH. For that, in that NaOH, 1 mole of sodium and 1 mole of oxygen and 1 mole of hydrogen is present. So multiply molar mass of each element by the number of moles of that element in the molecule, and add these three numbers, you get the 39.99 gram per mole. Some mole analogies are introduced in our syllabus. That is, 1 pair of as is equal to 2s. 1 dozen apple is equal to 12 apple. 1 gross atom is equal to 144 atoms. 1 mole of as is 6.02 into 10 raised to 23. 1 mole of apple is equal to 6.02 into 10 raised to 23, and 1 mole of atom is equal to 6.02 into 10 raised to 23 atoms. Now we see about mole convergence. So 1 mole is equal to 6.02 into 10 raised to 23 atoms or ions or molecules or formula units. 1 mole is equal to 22.4 liters of gas at STP. When the volume is considered, you take the 22.4 liter for 1 mole, and 1 mole is equal to molar mass of element, molecule or compound, etc. So here we see the mole island. In that the mole is marked the spot, and there are the three shapes: volume shape, gram and particle shapes. So if you want to go towards the mole from the volume, you have to divide the 22.4 liters, and if you wish to come from mole to volume shape, so you have to multiply by 22.4 liters. Similarly, if you want to go from grams shape to the mole, then you have to divide the molar mass, and if you wish to go from mole to gram shape, then you have to multiply by the molar mass. Okay. Similarly, if you wish to go from particles to moles, then you have to divide by 6.022 into 10 raised to 23, that is Avogadro's number. And if you wish to come from mole to particles, you have to multiply by the 6.022 into 10 raised to 23. Concisely, I would like to say number of moles. If number of particles are given and you have to calculate the number of moles, then number of particles divide 6 into 10 raised to 23. But number of moles are given and number of particles you want to calculate, then given number of moles multiply by 6 into 10 raised to 23. Similarly, if the number of moles are given and you want to calculate the concentration of aqueous solution, so you have to divide the given volumes, given number of moles by the volume. And if you wish to calculate the number of moles from the given concentration, you have to multiply by their volume. Okay. Similarly, if you wish to calculate the mass from given moles, then you have to multiply by the molar mass. But if the mass is given and you want to calculate the number of moles, then you have to divide by the molar mass. Similarly, for volume, if you wish to calculate the volume from given moles, then you have to multiply by 24 dm cube. And if you wish to calculate the number of moles from the volume, you have to divide by the 24 dm cube. So, mole calculations, these are the format. Okay. Now we moving to a forward examples of mole calculation. First example is that 45 grams of nitrogen contain how many moles of nitrogen? Okay. So, the 45 grams are given and you have to calculate the moles. So, you see the formula in that molecular mass is given and you have to calculate nitrogen, so that you want to divide by the 14. Nitrogen have the 14 its molar mass. So 45 upon 14, it comes out to be 3.213. Similarly, second example is that if 23.6 gram of water is there, so how many molecules of water is present in that? So for that, you have 23.6 gram of water is given, but for 1 mole of water, 18 gram of water is there, and for 1 mole of water, 6.02 10 raised to 23 molecules are of water is present. So you have to multiply 23.6 to the multiply by the 6.02 and divide by the 18. So you get the 7.89 into 10 raised to 23 molecules of water. Third example is that they give us the 35 liter of apple juice and they want to know how many moles of apple juice are present. So for that, 1 mole of apple juice have the 22.4 liter apple juice. So you have to divide 35 into 22.4. So it comes out to be 1.56 mole apple juice. Okay. Similarly, last example they given 0.07 moles of NaCl and they want to know how many grams of NaCl is present. So for that, you again for 1 mole of NaCl, 0.07 into 58.443 gram of NaCl. So it comes out to be 4.091 gram of NaCl. At a glance, we summarize this lecture, that is 6.022 into 10 raised to 23 is called as the Avogadro constant or Avogadro number. A mole is a collection of 6.022 into 10 raised to 23 particle. 1 mole is the amount of substance that contain as many particles as or entities as there are atoms in exactly 12 gram of the carbon-10 isotope. The mass of 1 mole of substance in grams is called its molar mass. Students, this statement is very important for you, that a mole is a collection of 6.022 into 10 raised to 23 particles. Thank you.